Hello class, today we're going to be finding the inverses of functions that have squares and square roots in them. So if you notice these steps here, what was written in orange remains the same as last lesson. The only thing that's new that I wrote was in the blue, because these steps in the blue is how to solve for these for these variables in these new functions, in these new square and square root functions. So I'm pretty sure that this was covered in Algebra 1-2, but just in case we may have forgotten, we need to remember that squares undo square roots and square roots undo squares. So for example, say if I have the square root of 3 here. Well, I can square the square root of 3. Oh, sorry, square it. It's 2. And I will actually get 3 out. So it undoes it. Just like how multiplication undoes division and division undoes multiplication, it's the same relationship. Likewise, if I had 3 squared and I wanted to undo the square, I could just take the square root. And that will give me 3. So let's first talk about the inverses of functions with square roots in them. Because depending on which way we go, whether we're squaring or taking the square root, it's going to look a little different. So let's start off with inverses of square roots. So let's go through an example, and we're going to just go right through these steps as we go through this example. So let's say we have f of x is equal to 3 plus the square root of x plus 4. Well, our first step, and this is no different than what we did last lesson, turn f of x into y. So we're just going to turn f of x into y. So we have y equals 3 plus the square root of x plus 4. Now we want to switch the variables and solve for our new y. Again, this is just like what we did last lesson. So x now equals 3 plus the square root of y plus 4. So y became x. X became y, and now this is where we need to solve for our new y. So this is what's new here, and let's go through these steps before we actually do it. So the first step is we need to get what is being squared or square rooted by itself. In this case, what is being square rooted is this y plus 4. So we're going to have to move over the 3. After we get the square root or square by itself, we need to undo the square or square root by doing the opposite operation. And then finally we need to finish solving for y. So let's excuse me, let's get this 3 over here so we can get our square, what is being square rooted by itself. So I'm going to subtract 3 from both sides. And we're going to have x minus 3 is equal to, now this canceled, which is what we wanted, is equal to the square root of y plus 4. Now we have what is being square rooted by itself. So now we can go ahead and now we can go and square both sides to undo that square root. So I'm going to square the right side. Remember, what we do to one side, we always have to do to the other side. And this square will undo the square root. So on the right side, all we have left is y plus 4. And on the left, I'm not worried about simplification at this point. You can just leave it as x minus 3 squared. And then finally, our last step, finish solving for y. Well, we have this 4. We need to go ahead and subtract 4 from both sides. And we're going to have y equals x minus 3 squared minus 4. Now, you may be thinking, well, why can't we combine this negative 3 and negative 4? Well, they're two different kinds of numbers because this negative 3 is being squared, and this 4 is not. So we can't combine them just yet. Or, yeah, just yet, unless we multiply it out, but we're not going to worry about that. And then finally, our last step, turn y into f inverse of x. So I ran out of room, so I'm going to write over here to the right. And I like to put the f inverse first, if you recall. So f inverse of x is equal to 3, or x minus 3 squared minus 4. And that's our answer there. Let's take a look at another example here. And this one is going to look a little different. Let's see. We're going to have g of x is equal to the square root of x minus 8. So let's go through these steps again. And when we get into the blue steps, we'll notice a slight difference here. So again, first turn f of x into y. In this case, it's g of x. So just g of x equals y. So y equals the square root of x minus 8. Switch our variables. Y becomes x becomes y. And now we need to solve for our new y. Now, what's different between this one from the last one is that the last one, we had this number on the outside of the square root. Well, here, the square root is already by itself, so this first step in blue is already done for us. So we can go ahead and go on to the next step, which undo the square of square root. Again, what undoes a square root is a square. So we're going to square both sides. And that, let's see, the square will cancel out the square root. So we're going to have x squared is equal to y minus 8. And then finally, just finish solving for y. Just add 8 to both sides. We want to do the opposite operation to this 8. It's being subtracted. So we need to add it. That cancels, which is what we wanted. So we have x squared minus 8 is equal to y. And then finally, last step, turn y into f inverse of x. So f inverse of x is equal to x squared minus 8. And there you have it. That's how we find the inverses of square roots. Now, let's move on to finding the inverses of functions that are squared. Now, I said earlier that it's going to look a little different, and I wasn't lying. It will look a little different. Inverses of squares. So let's recall something like this. I'm going to introduce a new notation to y'all. So this is the square root of 9, isn't it? And what the square root is really asking is saying, what number, when multiplied by itself, equals the number under the square root, or under the radical, is what they call this thing. So what number, when multiplied by itself, equals 9? Well, obviously, 3 is an answer, right? But when we are going this way, when we're taking the square root of something, we actually get two distinct answers. And that is because of this. 3 times 3 is equal to 9, but I can also think of another number that when multiplied by itself equals 9. And that is also, well, not also, but it's negative 3. Now, think about the logic behind this. This one, the 3 is pretty obvious. 3 times 3 is 9. But negative 3 times negative 3, remember what happens when we have two negatives that we're multiplying together. They equal a positive. So we also get positive 9. So that's why our two answers are 3 and negative 3. Now, let's see. I can write my answer like this. Y equals plus or minus 3. And this is the new notation that I want to introduce to y'all. it's read as plus or minus. And it's just saying that you have two answers. One is going to be a positive 3. The other one's going to be a negative 3. So let's keep that in mind as we're going through these examples here, okay? So let's start off with, say we have g of x is equal to 3 plus x minus 1 squared. Again, steps, turn f of x into y, or in this case g of x. So y equals 3 plus 1, or x minus 1 squared. And then switch the variables. We should be getting pretty good at that by now. X equals 3 plus y minus 1 squared. And now we need to solve for our new y. So we're in the steps in blue now. Get what is being squared or square rooted by itself. Well, in this case, we have this 3 hanging out there. So we want to get rid of that. So we're going to subtract 3 from both sides. It's going to give us x minus 3. And that's going to cancel this out. So equals y minus 1 squared. Now, we have what's being squared by itself, so let's get rid of the square. Let's do the opposite operation of squaring. So let's take the square root of both sides. Now this square root will cancel out the square. So on the right side we have y minus 1. Now on the left side, this is where this new notation, this plus or minus, is going to come into play. The side that doesn't have your y in it, that you took the square root of, it's going to be, wrong color, it's going to be plus or minus the square root of whatever that is, in this case x minus 3. So again, put the plus or minus in front of the side that doesn't have your y in it. Okay? Now we can finish solving for y. So it's y minus 1. We're going to do the opposite operation, add 1 to both sides. And we can't add this 1 to this negative 3 because it's being square rooted. So instead we're just going to write it right up front. 1 plus or minus the square root of x minus 3 is equal to y. And then finally, just turn your y into f inverse of x. And again, I like to write it by itself, or sorry, I like to write it first. So f inverse of x equals 1 plus or minus the square root of x minus 3. And that's my answer there. So let's go through another example. It's going to look a little different, but the same process. In fact, this one's easier. It's the square version of no, I don't know where I'm going with that. Okay. All right, so let's take a look at f of x is equal to x plus 5 squared. And go through these steps. So turn f of x into y, not bad. Y equals x plus 5 squared. Switch the variables now. Y becomes x becomes y. And then now we do our steps in blue. So again, look at what the first step in blue says. It says get what is being squared or square rooted by itself. Well, in this case, that's already done for us. What is being squared is already by itself, so we can just go on to the next step. That's okay. We need to undo the square or square root. So we're going to do that by taking the square root, because it undoes a square. So the square root undoes the square. So on the right side, what we're left with is y plus 5. And on the left side, we have the square root of x, but not just the square root of x. We have plus or minus the square root of x. Remember, we need to put that plus or minus in there in front of whatever we square rooted on the side that doesn't have the y. Okay? And then finally, just finish solving for y. So we're going to subtract 5 from both sides. y is equal to negative 5 plus or minus the square root of x. And then finally, last step, we want to turn y into f inverse of x. So f inverse of x is equal to negative 5 plus or minus square root of x. And that's that. And that's all I have for you. We did both ways. We found the inverse of functions that were square rooted, and we found the inverses of functions that are squared. So let me know if y'all need any help, and I'll be here. Have a good day.